Hello students. So here now in the thermal expansion of water, already we have seen the effect of change in the volume of liquid when we consider it inside a container. Okay, apparent change in the volume, the real change in the volume, all those things just we have seen. Now here this is another important concept called a triple point. Okay, triple point. So what is a triple point? We will analyze this graph. Before that, let me tell you, triple point is a point of temperature and pressure, or we can say the values of temperature and pressure where the solid form, liquid form and gaseous form, all the three forms exist together. Okay, so suppose if we consider a mix of ice and water, we know ice and water mix is there. So along with that, if gaseous form is also there, then ice, water, gas both will be there. Generally we know when we boil water, only after 100 degrees Celsius the water will convert into steam or into vapor form. General case, that is in our atmospheric pressure or in a normal cases. Suppose if the pressure changes, okay, this can happen even at other temperatures also. Okay, general case is ice will be there. This ice could be at -5 degrees Celsius, then -1 degree Celsius, till 0 degrees Celsius ice can be ice. Once if it crosses 0 degrees Celsius, ice will convert into water, and water can exist between 0 and 100 degrees Celsius. After 100 degrees Celsius, water will become what? It will become steam. This is the usual procedure. But if this is applicable under the atmospheric pressure, the pressure which we live, okay, which we survive. If the pressure changes, okay, this behavior will change. So there one concept called triple point comes. Now you come to this graph. Okay, you come to this graph. So in that graph here, you can see in the y-axis we have marked the pressure. Okay, in y-axis you leave this one, just look at this. In y-axis we have marked the pressure, atmospheric pressure. So here this is at 0 pressure, this is 0.006. this is much lesser than that of atmospheric pressure. Atmospheric pressure is how much? 1 atmosphere. Then what about this? This is very high pressure, 218 atmosphere. Okay, and in the y-axis we have marked T, temperature, in what unit? Degree Celsius. Okay, this is in degree Celsius. So this is 374 degrees Celsius. This is 0.01 degree Celsius, and here it is -220 degree Celsius. Okay, so this is a graph of water. Okay, water. You can see here, if this is the origin O, so from here you can see a curve here. So this is OC, and this is CB, and this is CA, or OC, AC, BC. See, now if I say at 0.006 atmosphere and any temperature less than 0.01 degree Celsius, okay, or I can say, I will show you the different forms, like see, if this is solid, I will mark with the green. Okay, I will mark with the green. This is solid. Okay. Okay, and this is a liquid. That is, water is in liquid form. So here the water is in solid form, and this red color I shall show you, the water is in vapor form. So see, if this is 0.01 degree Celsius and if this is 0.006, then at this point, that is at a pressure of, at such a low pressure. Okay, so suppose if we mark 1 atmosphere will be between this. Okay, somewhere here it will come. Okay, somewhere here it will come. Okay, so at such a low pressure, okay, 1 atmospheric pressure is the normal temperature pressure condition, not that one. At very low pressure, at 0.006 atmosphere, at such low pressure and at a temperature 0.01, not 0.00, 0.01, not 0. 0 we know, 0 degree Celsius we know, just 0.01 degree more than that. At that point, at these two values, at this pressure and this temperature, here they coexist. Okay, so first thing we can say is triple point is the value of temperature, and pressure where, okay, solid, liquid and gaseous form coexist. So at this pressure and temperature, you can see it, there's solid, liquid, vapor, all the three forms will be there. Okay, clear. Now we will analyze this graph. This graph is of water, and we know at 1 atmospheric pressure, that is the normal pressure at 0 degree Celsius or at minus 5 degrees Celsius, minus 10 degrees Celsius. At minus 10 degrees Celsius, at 1 atmospheric pressure, what will be the form of water? At minus 10 degrees Celsius, at 1 atmospheric pressure, the form of water is solid, ice. Okay, let us see that here. Now what is, somewhere we can put 1 atmospheric pressure. 1 atmospheric pressure will be above this, above 0.006. okay, somewhere here we can assume. Then at minus 10 degrees Celsius means this is 0.01, so somewhere here it is 0 degrees Celsius. So minus 10 degrees Celsius we can, somewhere here we can take, and okay, at minus 10 degrees Celsius, and if we take 1 atmospheric pressure, this is 218, so we can get somewhere here. So I am assuming that this is minus 10 degrees Celsius. Okay, this is I am drawing a rough figure, but it should match the criteria, that's it. Okay, accurately we cannot plot here. So minus 10 degrees Celsius, okay, if this is 0.006, I can take 1 atmosphere here. Then what about this? At this point, this is ice. This is ice. Correct or what? This is our normal scenario. At 1 atmospheric pressure, at a minus 10 degrees Celsius, that is ice, no worries. Then at say for example 30 degrees Celsius, our room temperature and 1 atmospheric pressure. Okay, what will be the condition? Okay, suppose if this is 0, 1, okay, and this is 374, such a big difference is there in the scale. Okay, now I am taking somewhere here I am just taking 30 degrees Celsius. Now if this is 1 atmospheric pressure, I can get, okay, just slow, a little manipulation I am doing for your understanding purpose. Okay, we will make the curve like this. Okay, so at somewhere at a 30 degrees Celsius, okay, at a 30 degrees Celsius, okay, at 1 atmosphere we are getting somewhere here. So 30 degrees Celsius, 1 atmosphere, what is this? This is in the water form. Actually, even beyond this 30 degrees Celsius up to 100 degrees Celsius, we should get what? Water form. So this curve should move a little bit further. Okay, hope my intention you understood. Okay, so we have taken like this. Even 30 degrees Celsius also, such a big scale difference has happened. So let us bring it this side. Okay, so for 30 degrees Celsius, okay, for 30 degrees Celsius, if we consider like this 1 atmosphere, then that is in water form. Now suppose if we move further, see this 1 atmosphere pressure, if we further again extend, and if we understand this is 110 degrees Celsius, 110 degrees Celsius, this is what? Steam. Okay, so at 1 atmospheric pressure, below 0 degrees Celsius, this is ice. Between 0 and 100 degrees Celsius, that is water. Above 100 degrees Celsius, that is around 110, I have marked here steam. So this is the normal situation. So normal situation is this. Okay, ice, water, steam. Okay, understood or what? Normal situation is that. Now when we increase the pressure, decrease the pressure, situation will change. Okay, understood or what? So that is the triple point. Okay, now clear, note it down. Whatever points I said, please pause the screen and write all those points. Okay, nothing I said at 1 atmospheric pressure, minus 10 degrees Celsius ice, 30 degrees Celsius water, 110 degrees Celsius steam. At 0.06 pressure, very low pressure, that time at 0.01 degrees Celsius accurately, the triple point of water we are getting, which is nothing but the coexistence of solid, liquid and gaseous form of water. Okay, these many things we discussed. Clear? Fine. Now what is sublimation? Sublimation is nothing but conversion of solid directly to gaseous form. Generally what will happen, if we take ice will become water will become steam. But ice directly to water, but directly to steam or directly to vapor form, that also happens, right? So sublimation is nothing but directly from solid to vapor. So this is the line that is differentiating solid form and vapor form. So I could say this is nothing but sublimation curve. So this is sublimation curve. What? OC is sublimation curve. Okay, sublimation curve. OC is sublimation curve. Clear or what? Okay, so I have written here OC. So I will write here, this curve OC is what? Sublimation curve. Sublimation curve. What happens here? So this is OC. So here, suppose if the pressure is very less, 0.0001, something like that. Okay, so at that pressure, okay, or we can say at a very low pressure, a very small temperature change can convert solid into vapor form. Okay, so that is what is OC, is the sublimation curve. Now you can see here liquid to vapor form. So here, suppose if the pressure is 218, if the pressure is 218 at a very high temperature, liquid will convert into what? Vapor form. Same way you can see here at somewhere around 2 atmosphere, even at a less temperature also, liquid can convert into what? Liquid can convert into vapor form. So this one, this AC or BC, okay, so here BC, we'll write this, okay, BC or CB, okay, this is nothing but vaporization curve. This is vaporization curve. And here you can see AC, solid will convert into liquid, that is nothing but fusion curve. AC is fusion curve. Fusion curve. What is fusion? Fusion means conversion of water into ice. Okay, liquid form will become the solid form, that is what is fusion. And melting is what? Solid form will become liquid form, that is what is melting. So vaporization is nothing but liquid will convert into what? Vapor. Liquid will convert into vapor, vaporization. Same way, liquid when vapor convert into liquid, that is called condensation. Okay, so just OC is what? Sublimation curve, solid to liquid, or liquid to solid to gas, solid to vapor, or vapor to solid, that curve OC. Same way BC is vaporization curve, liquid to vapor, vapor to liquid. Same way AC is nothing but fusion curve, that is solid liquid. Okay, is it clear? So triple point is the point where pressure at such values of temperature and pressure where solid, liquid and gaseous form coexist. Clear? Now we need to do some more analysis. Okay, now shall I erase this? So here the vaporization curve, sublimation curve, fusion curve, everything together. Okay, clear? Okay, now what is the boiling point of water? Boiling point of water is 100 degrees Celsius. So suppose if this is 0.01, so we have taken here 30 degrees Celsius. So this water will convert into vapor at 100 degrees Celsius. So if I consider this as 100 degrees Celsius, just okay, this is 100 degrees Celsius, that is the temperature at which water converts into vapor. Okay, so boiling point, okay, so what happens? Water converts into vapor, water converts into vapor, water converts into vapor. This process is called vaporization. Vaporization. And if vapor converts into water, this is called condensation. Both are to and fro process. Okay, vaporization, condensation. So boiling point of water is what? 100 degree Celsius. Okay, at what? At 1 atmospheric pressure. Boiling point of water is 100 degree Celsius at 1 atmospheric pressure. Now let us see. When we increase the pressure, boiling point shifted to this point. Again, when we increase the pressure, boiling point shifted to this place. This is temperature scale. That is, when we increased the pressure, what happened here? Boiling point is shifting. Boiling point is not just 100 degrees Celsius. Boiling point is the point where water form will convert into what? Gaseous form. So when we increase the pressure, this conversion point is drifting towards the right. So when we increase the pressure, what happens here? Boiling point increases. Important point. Okay, when we increase the pressure, boiling point increases. Okay, same way we can see when we decrease the pressure. This boiling point, what happens? Boiling point decreases. When we decrease the pressure, boiling point decreases. Okay, not this point. Clear? Fine, note it down. Important points. Clear? Pause the screen and note it down. Shall I erase this now? Boiling point, water, vaporization, 100 degrees Celsius, 1 atmosphere, vaporization, condensation. Right. Okay. Now we are analyzing the graph for water. Okay. Now what about melting point? So generally melting point is 0 degrees Celsius for water at what pressure? At 1 atmospheric pressure. So melting point is 0 degrees Celsius at 1 atmosphere. For whom? For water. Okay, for water. So what is that actually? Ice will convert into water at a melting point. So this process is called what? Melting. Now the reverse process, water will become ice. This is called fusion. Clear? This is called fusion. Now what will happen to melting point based on the pressure? So suppose again, if we consider this is minus 10 degrees Celsius, this is 0.01. So suppose if we consider 0 degrees Celsius, somewhere here, if I consider here, suppose if I consider 0 degrees Celsius, this ice will become water at what pressure? At 1 atmospheric pressure. Now if I increase the pressure, now what happens here? This melting point is shifting leftwards. See, when I increase the pressure, melting point is shifting leftwards. So we can understand that when pressure increases, what is happening to melting point? The melting point is decreasing. Okay, so when I increase the pressure, melting point is decreasing. When I decrease the pressure, when it comes down, melting point is shifting rightwards. So melting point is increasing. Clear or what? Okay, so when I increase the pressure, boiling point will increase. When I increase the pressure, melting point will decrease. Okay, you can observe from this graph. Clear or what? Okay, so these are the points which we need to understand from the graph of triple point. Clear? Okay, note it down. Okay, so here students, we need to understand certain things are like when we were studying the conversion of scales, when we were studying about thermometers, we have fixed the upper fixed point, lower fixed point. So we need to understand one thing, like at lot of pressure difference is there. If there is lot of pressure difference, the melting point, boiling point, all these things are changing. So even at such change in pressure, okay, if it is not atmospheric pressure, obviously the upper fixed point and lower fixed point itself is changing. Okay, so if there is a method like instead of having 0 degrees Celsius considering as melting point or fusion point of water, there is a practice of choosing this triple point 0.01. This point is actually fixed. This is constant for a material. Okay, because this is also fixed, this is also fixed. Triple point, if we say triple point will happen only at this pressure, triple point will happen only at this temperature. So triple point is a constant value for a material. If it is water, it is like that. For carbon dioxide, it is different. Likewise, so we can choose triple point as the fixed point in thermometers also, because that one is actually fixed one. But otherwise 0 degrees Celsius can change, that lower fixed point can change based on the pressure. Okay, so hope you understood that importance of triple point. Clear? Now this was about water. Now this figure is also given in NCERT, so I have drawn that also. That is also same behavior, but the values are different. Here the triple point is minus 56.6 degrees Celsius is the temperature, and the pressure, corresponding pressure for triple point is 5.11 atmosphere. Okay, this is for carbon dioxide. So same way. Okay, slightly curve is different. Here curve is different. Okay, but the analysis we must do in the same way. Okay, so this is given in the book. This is of carbon dioxide. Okay, carbon dioxide. So I hope if they give any figure, okay, this is the triple point diagram of so and so, you know how to tell the behavior of the thing. Okay, whether melting point is increasing or decreasing, boiling point is increasing or decreasing, all this behavior we should be in a position to analyze and give the correct option. Okay, so that is the what if the difficult question comes, okay, we should be in a position to analyze and give the results. Okay, this is how we should analyze the graph. Clear? Shall I erase this? Okay, hope you understood. Now students, we have seen the triple point of water. Now we will see another regarding this triple point by analyzing the triple point graph, or by analyzing the graph where we study about triple point. We have observed that the melting point decreases with increase in pressure, and boiling point increases with increase in pressure. So regarding melting point, a practical situation which we can see. All these phenomenon we can see in nature. Okay, we can see. So here, suppose if this is an ice slab, this is, suppose if this is an ice slab, I am going to explain about regulation. Okay, a phenomenon called a regulation, which I am going to explain. Okay, this we can explain under the lights of the previous topic, that is the triple point graph, or the melting point, boiling point relation with the pressure. With that knowledge only we can analyze this. Suppose if this is an ice slab, if we keep a thin string or a small piece of cloth or a thin string, okay, suppose if we put like this, what will happen? Because of this weight of this string, because of the weight of this string, what will happen? This ice slab will this point will experience, this will experience a pressure. We know when pressure increases, this is ice slab, melting point will decrease. So the melting point of this region, okay, at that thin strip, that will decrease. So already this is ice. Okay, when melting point decreases, what will happen? This area, the surrounding area, this will become water. This will become water. So what will happen? This string will go down. When the string comes down, say for example, if the string is here, okay, that is from here it came down. So that time this part here, now the weight of string is not there, the force due to string is not there, where this upper part, when this became liquid, the string will come down, string will pass through it, and the upper part of the string, pressure decreases, where this upper part. So this part will become ice. This will become ice. Likewise, so this part will become water. This part will become water, and the string will come down. So what happens is, if we take an ice slab, if we take one ice slab like this, and suppose if I keep a wire like this, are you able to see the wire of my mic? I am putting like this. Okay, so if I keep like this, if this is ice, this part will become water because of the pressure due to this wire. When this pressure increases, this part ice will become water because melting point will come down. So what will happen? This string will go down. So that time the upper part of this string, that will not have any pressure because the pressure of the string has gone down. So the upper part, the pressure will become normal and they will convert back to ice. So what will happen? Now the string will be here. In between the slab we will see the string. Likewise it will go, and finally the string will come down, but division of slab will not happen. The slab will not be divided into two pieces because it will join back once the string comes down. This process of freezing is called the regulation. So here which we need to understand is, slab will not be will not be divided into two pieces. The slab will not be divided into two pieces. So regulation is nothing but the process of refreezing. Okay, so refreezing happens here. So the process of refreezing, once the pressure comes down is called regulation. Okay, so this thing is discussed in our textbook NCERT, so you can note down. Okay, clear? This is what is regulation. We can see clear example of melting point dependency of pressure with this. Clear? Okay, so change of state will happen in this case when we change the pressure. Okay, ice will become water. Okay, what happens here? Ice will convert into water. Okay, when pressure increases. Temperature is constant here. We are not doing anything with the temperature. Okay, then again what will happen? Water will become ice when pressure decreases. Pressure increases means what? Here also T constant. So when wire applies weight, pressure increases. Okay, when wire goes down and doesn't apply weight. Okay, so this overall process is what is called a regulation. Clear? Note it down. See students, here you can see a graph. So this graph is explaining the anomalous expansion of water. There is some difference for water when we compare to other materials. Generally we know if we increase the temperature, volume will increase. Okay, if the pressure is constant. So suppose if we take a vessel of water here, and if we are giving heat, and if we are increasing the temperature, the pressure is atmospheric pressure. We are not increasing its height, neither we are going down or up. We are not going to hill, we are not going to seaside also. We are keeping this in a place where we are not neither increasing its height or decreasing its height. So here the pressure, atmospheric pressure is constant. So a practical natural situation is atmospheric pressure, and that is constant pressure. So in such a situation, if we increase the temperature, we know the volume of anything, any substance will increase. Now if we take water, you can see in y-axis I have taken volume per mass. So here these are the volume, observed volume for, say for example, 1 gram of water, and this is temperature. Now here you can see at 0 degrees Celsius the volume of 1 gram of water, say example 1.0015 centimeter cube per gram. Now when I increase its temperature till 4 degrees Celsius, its volume is decreasing. Or I could say here till this point the coefficient of volumetric expansion is what? Negative here. This is negative here till 4 degrees Celsius. After 4 degrees Celsius, then its behavior, the behavior of water is just like the normal expansion of other materials also. So it is only after 4 degrees Celsius the coefficient of expansion of volume, okay, temperature coefficient of expansion, temperature coefficient of volume is positive, negative till 4 degrees Celsius and positive after 4 degrees Celsius. Now, what is its advantage when we look at the nature? See, obviously here, if the at 4 degrees Celsius, if the volume is minimum, here if the volume is minimum, obviously the density will be what? Maximum. If the volume is minimum, density will be maximum. So in winter, if we take a water body, if we take any water body, okay, if this is water, where that 4 degrees Celsius water will be? Where the 4 degrees Celsius water will be? 4 degrees Celsius water will be at the bottom. Here the 4 degrees Celsius water will be there. So here 4 degrees Celsius water will be at the bottom. So even here what will happen? Okay, here atmosphere. So at this point here there can be ice formation. Okay, so the place where it is exposed to atmosphere, ice formation can happen. So the more or the denser part will be where? It will be at the bottom. We have studied in fluid mechanics, as if the density of the material is more, it will come to the bottom. If the density is same, it will float, or density is less, it will be floating with some percentage inside the water. All those things we have seen, Archimedes principle we have seen. So since the density is maximum at 4 degrees Celsius, at the bottom of the lake some water will be there. If this will be 4 degrees Celsius, water will be there at the bottom, or 2 degrees Celsius or 5 degrees Celsius, all this water part will be at the bottom. Here comes the ice. Beyond this only ice, that is less denser, so that will be at the top. So the advantage is the animals, aquatic animals can survive here. Okay, so in winter aquatic animals survive here. Okay, otherwise what will happen? This will come down. Okay, everything will be frozen and animals cannot survive. So animals can survive at this in the bottom of the lake where water will be present. Okay, so this is about the anomalous expansion of water. Okay, so students, now we have covered the expansion of solids, expansion of liquid, and various behavior when we consider water and all. Okay, now we will do some problems about this in another session. Okay students, thank you, goodbye, good luck.